is Anthony Cummins, Physics 221, Video Homework 2. The objective is I can use a computer to loop through an iterative process to predict the future motion of an object experiencing a changing net force. The problem I created was one of the spaceship's fuel compartments was damaged in an asteroid storm, causing most of the fuel to leak out. Needing an alternate way to change course back to Earth while using minimal rocket boosters, the astronauts decided to use a nearby moon to slingshot the ship. The ship is moving at a velocity of 1,000 meters per second when it's located at 5 times 10 to the 10th 0 meters. The ship has a mass of 500,000 kilograms and the moon has a mass of 7 times 10 to the 27th kilograms. Determine the trajectory of the ship with a time step of 1 day, assuming the moon is at the origin. So we must plug in all our values into GlowScript, starting with defining the constants. First we have the mass of the moon, mass of the ship, and the gravity constant. Then we have our initial position, our initial velocity, and our equation for momentum. Then we have initial time of 0, and then change of time 1 day in seconds, which is 86,400 seconds. Then we have our way of visualizing our ship and moon. The ship is red and the moon will be blue. Next we have to create our loop for iterating 275 times at a rate of 100. And then we calculate our net force, which is the gravity constant times the mass of the moon times mass of the ship times r hat, which is calculated with the equation right above, and then divided by the magnitude of position. Then we calculate our new momentum by adding the initial momentum plus the newly calculated momentum in each iteration. And we get our new position by adding our initial position plus the new position calculated in each iteration. So then if we run the program, you see our ship starts up there and then gets a nice slingshot around the moon.